Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous couple of videos, we had an overview of Circe and we also took a deep dive into codecs. Today we're going to talk about a couple of external modules that we use together with Circe. Among them are the integration with Refined, the integration with the convict library, the integration with fs2, which is a streaming library, and also how can we talk about JSON without talking about the web. So we're going to have the integration with http4s and even Scala.js. I know that this video is going to be way too long, so let's get right to it. This is where we left off. I cleaned it up a little bit, so it's pretty much the same as we began the previous video. We have our typical key 1, key 2. We have our data. We're using the configured JSON codec annotation instead of the automatic derivation, and we have a simple example where we just read it in, and also I'm going to say read it out, right? So we basically decode it and encode it back. We're going to start with the integration with Refined. And if you haven't seen my video about Refined, first of all, you should. But the quick summary is that Refined allows you to, well, refine your types with an extra predicate. So for example, an integer allows you to have both negative and positive integers. However, you might want to have only positive ones, right? So the integration of Circe and Refined is basically one import. First, we need the library. Let's go to our build. We're going to use way too many libraries today. So we're going to go over here and we're just going to say Refined. Okay, let's make sure that they're alphabetically sorted. That was very close. Okay, like this, and yes, please import the changes for me. Let's go back to our main, and oh, by the way, unless you're just playing around, I always recommend you to specify the exact dependencies that you need, right? So Circe Refined actually has a dependency on the actual Refined. So let's actually bring it in. In fact, let me show this to you. So let me wait for Bloop to finish. Yeah, perfect timing. So if I go over here, and we're going to see our not Docker libraries, and we're going to find a Refined, which is over here. So it uses the version 0.3. No, this is the Circe Refined. Hold on, where's the Refined? Here. So it uses the 0.9.12, and I happen to know that the latest one is actually 0.9.13. So it's not that we really need it, but you know, if we can, then why not? Let me actually copy paste it for you. So it's going to be over here. Okay, 0.9.13, and yes, please import the changes again. And once it finishes importing, actually this view will refresh, and we should see a 13 over there. And there we go. It just refreshed automatically. Now we can collapse this, and let me switch back to this and bring it away. So all we need to do is we need to go to the top, and first of all, we're gonna need we're gonna use some of the refined types. So we're gonna do EU template refined types, and because this is just demonstration, we're going to say all. Okay, so now we're going to go and we're going to say, okay, let's say that inside of key 1 our value is not going to be a string, it's going to be a non-empty string. Okay, so we're going to do a non-empty string like this. In fact, for key 1 we're actually also going to use this thing over here like this. I believe this is what we need. Let me throw this out for now real quick. I believe that this is how I imagined it to be. And now it doesn't compile because it says, okay, it can't be an any val. Hold on. It can't be an any val like this. Okay, so now it says could not find an implicit value for key 1. Okay, so we just need another import, and this import, so this import that we're using over here, it comes straight from Refined. Now we also need to have the import that comes from the integration with Circe and Refined. Okay, so we're going to do import io.circe refined underscore like this. All right, let's see if this is enough. I actually don't remember if I did this or not. No, I didn't. Let me actually see. Hold up. How did I do this? I believe we need to use non-empty string over here. Non-empty string. Yes, no, maybe yes. So this is how I had it. Okay, so now if this string is empty, for example, it's going to say predicate is empty, did not fail, which is exactly what we want. All right, let me revert this real quick. Now, another thing that I want to show you is that Circe has a built-in integration for accumulating your errors. So, for example, let's say that our key 2 is not going to be just integer. Let's say that it's going to be a positive integer. So let's break both of them. Let's say this is an empty line and this is a negative 27. Okay, we're going to see only one error message. Now, originally, I wanted to show you how to accumulate errors manually. However, now that I have the script for the entire video, I know that it's going to be way too long. So we're just going to go straight into the Circe integration and see how Circe does it for us. Essentially, remember that we have have this this helper over here, read JSON from, was a bunch of helpers over here. At some point, it's going to call decode. If we jump into decode, we're going to see that there's also decode accumulating. So we're going to introduce a couple of helpers that are just going to call this one, okay, instead of doing the whole thing manually. We're just going to go over, let's go back. Okay, so let me grab the URL into, which is this one, and I'm going to go down and I'm just going to paste it over here, right? And we're going to call it URL into accumulating, okay? And just before I jumped into decode, notice that it returns a validated null, right? Remember my video about error handling, right? So this is going to be a validated, where on the left we're going to have a non-empty list of error, okay? I actually want to switch it just for fun because we're using either everywhere. I want to keep using either here as well, okay? So now it's going to return not a validated null, it's going to return either neck, okay? So it's going to return either neck of throwable, okay? So now we're going to do from URL, so same as before. In fact, I'm realizing that I copied the wrong. We need to do this one as well, but I wanted to copy paste this one, right? So this is the beginning where we parsing a string first into URL and then into our actual data, okay? So let me actually have this one first. So we're going to have this one. It's going to be an either neck, and this is going to be URL into accumulating, okay? So this is going to be our other URL. Let me do this. So before it goes into URL into accumulating, actually, so this is going to go like into this one, okay? So before it does that, we're just going to convert our validated to an other neck, and yeah, that's pretty much it. So now we can actually go and have this one, okay? So we're going to do from URL to map blah blah blah. Before we're going to do this decode, we need to do to other neck. Okay, but now we also need to call decode accumulating. Okay, so we're going to do decode accumulating, and we need to have an underscore over here. And now this is going to give us a validated, so we need to convert it back to an other so that we can do left map, and we're going to put it into a non-empty chain because it returns us a non-empty list. Non-empty chain is sort of like the newer version, which allows you, it allows you to have a constant one append as well, which is what you want when you're accumulating errors. Okay, so let's do from non-empty list. Let's see if I need any imports. Yes, I need the data. Okay, cats implicits, and import cats data. Let's see if that's enough. And yeah, it's enough. So as you can see, no, hold on. Yeah, it's enough if we actually call it. So we can go resource into, oh, we're using the resource. Hold on, I forgot to do the resource one. Okay, so let's do, where is our resource? Okay, so we have resource into. Let's also have resource into accumulating. Okay, so it's going to be the same thing. It's going to be an either neck, and all we need to do is we need to go over here and do to either neck. And also instead of URL into, we're going to do URL into accumulating. And as a reminder, I'm going to upload it to GitHub so that you have the entire example. Okay. So now all we need to do is over here, I'm going to say instead of reading the resource into data, we're going to resource into accumulating. Okay. And now it's not going to be an either. It's going to be an either neck like this. And we also need to have either neck, which is over here. Gets data. All right, is that enough? And yes, it's enough. So as you can see, we see the chain with both errors. Okay, so this one was not empty, and we also have the 27. Okay, let me actually fix them real quick like this. And there we go. Everything works exactly the same as before, but now we actually have the accumulating behavior. And notice it's actually very important that, hold on, empty and 27, that you also see where the error is happening, okay? Because we're using the, in the original example where I wanted to show you how to do this without circe, we wouldn't be able to get the information of the cursor. Now, let me clarify a couple of things before we move on to the next integration. The first one is that this accumulation of errors, it technically doesn't have anything to do with refined, right? I just waited to have a better example for it. And another thing is that you might be wondering, why isn't accumulation of errors a default behavior? And honestly, I have no idea. My suspicion is that probably if you're dealing with some large JSON, you might not want you know, if it fails already in the first line, like why would you go through like 400 other ones? So I believe that this is why you have like, you know, both versions. You have the decode and you have the decode accumulating. All right, let's talk about the next item on our bucket list, which is the integration with the lightbend config library. And if you have seen two of my, well, technically actually 3 videos about the lightbend config library, it uses the format called hcon, which is a superset of JSON. And so instead of using something like pure config, we could actually use circe just to read this JSON in. Okay, so the first thing that we do is we're going to go back to our build, and we're going to have the integration. And notice that this integration is going to be the first one that is sort of like outside of this realm, so it's not going to have exactly the same version. Okay, we're just going to have it over here. It's going to be io.circe, right? So it's in the same, you know, it's in the same organization. However, the version is different. Okay, so it's 0.80, which is the latest one. And again, you know, same as before, it's going to bring in the dependency on the type-safe config library. However, it's going to rely on some older version. So let's go and specify it ourselves. Okay, so let's go over here. Let me paste it. Let me show that everything is sorted. And also as a reminder, you know, the config library is a Java library, right? So we have only one modular symbol. Okay, import the changes. All right, and I believe, like at least in the preparation from my video, it actually did not really work with the with this configured JSON codec annotation. I have no idea why. Okay, so if we go back to our terminal, it seems like it's fine, but if we clean, right, and try to run again, at least during the preparation, yeah, it didn't like this this annotation for some reason. Okay, so for now we're just gonna remove it and switch to automatic derivation like this, and now everybody's happy again. Let's actually go and fix this guy like this. Okay, so now everything is back to green. Okay, so the only thing that we need to do is we need to have let's actually go and clone this one. So let's go over here, let's copy, and let's paste over here. So now this is going to be application.conf. Okay, and now because we're actually using application.conf, we might as well use the, you know, the better. We could leave it like this, right? But if we could actually use the hcon syntax. Okay, so we don't need the quotes, and you know, we can use the equal sign over here, and you know, we don't need the comma, and I believe we actually don't even need these guys. Okay, so I believe this is enough. So if you compare, you know, the human config is a little bit, you know, it's even more readable. It's actually kind of closer to YAML. And by the way, I'm not sure if I mentioned this in the previous video, but you can actually use the circe YAML integration. I believe it uses the snake YAML library in the back, and you can actually, you know, read in the YAML with circe. All right, so now let's go into our read JSON from helper, and I'm going to just add a couple of more things over here. So we're going to do import type-safe config factory, right? This is all we need. Let's actually bring it down to over here, right? So I like to kind of, I never mentioned this, but the way I group my imports always is first I have the Java dependencies, then I have the Scala dependencies, and then I have everything else, and then I have my you know, my own things, right, from the current project. And every group is sorted alphabetically. Okay, so we have Java, Scala, all the dependencies, and then my stuff. Okay, so technically it's like 4 groups, but it's, you know, every group can be divided into subgroups. All right, and I kind of wish that you know, something like Scala FMT was able to do this. However, Scala FMT, you know, it works on the syntactical level, and in Scala, you know, import can go really crazy, so you actually need to go into the semantics as well. Scala Fix might be able to do this at some point in the future. All right, I believe it actually can do this already, but like in a very limited scope. Okay, so now let's go and add one more. So we're gonna have default ho config, like because it's hcon, into accumulating. Okay, so we're only going to use accumulating for the config because for the config, you know, we always know that it's going to be small enough. It's fine to accumulate the errors. We're reading it only once in the beginning of our application. Okay, so it's going to be either neck of throwable or a, and it's going to be either catch non-fatal config factory .load, and we're going to do the same trick as above to either neck, and we're going to do flat map, and we're going to call another helper that we're going to define in a couple of seconds, config into accumulating a. Okay, let's see if I made any mistakes. All right, not found value config factory like this. All right, so this is the one that we need to define. I'm gonna go over here, I'm gonna do def like this, so it's gonna have an a that has a decoder, but now it actually needs to have the config passed in and returns either nec throwable or a. Okay, and it's going to do io.circe.config.parser. So I'm not importing this because we're actually importing io circe parser, right? And so this way we're making sure that we're not using the the default parser that parses JSON. We're using the one that comes from io circe config integration, right? So we're using the one that comes from this one. Okay. So we're going over here, parser, and we're going to do dot decode accumulating a, and we're just giving it the config. Let me actually save the file so that scala.fmt can do its job like this. All right, and now we need to go and do to either, and also do left map non-empty chain dot from non-empty list like this. All right, and this is throwable like this. All right, and we also need config. Did I import only one? Oh yeah. Like this. Yeah, there we go. Okay, so now we can go back to our main and actually use it. So we can do, so instead of this guy, let me comment out the tabs, and we can do actually let me copy this whole thing. Okay, because I designed it like in a way that it's very similar. Okay, so this one is going to be called from config decoded data, and we're going to say so we don't need to pipe this in there, so we're just going to say this, and we're going to remove the pipe. We're still going to use these guys. Okay, so instead of resource, we're going to say how did I call it? Default. Yeah, this one into data. In fact, I believe this is actually all we need. And yeah, there we go. So we're reading exactly the same thing from our application.conf. Let's change the number just so that we're sure that it's actually coming from there. And yeah, it does. Super cool. All right, it's time to bring out the heavy guns and talk about fs2, which stands for Functional Streaming Library 2. So if you never heard about streaming before, I would like to remind you that at the end of the Homegrown Collection series, we actually have 5 or 6 videos where we're implementing streams ourselves. And they actually ended up being functional streams because we're wrapping IO in there. And also, if you never heard of IO, this part is going to be really tricky. You might want to watch my monods playlist. So in fs2, you create these streams, and technically, because it's very functional, you don't actually create streams, you create descriptions of streams. And because it's a stream, it describes not just a computation like IO would describe a computation. A functional stream actually describes an incremental computation, right? And so later, you can decide how, you sort of compile it, and then you decide how you want to drain it. You want to drain the whole thing, or do you want just the last element? Do you want to collapse the whole stream into one thing, or and so on. fs2 is an awesome library which totally deserves its own video, or in fact multiple videos, and I'm sure that we're going to have videos about them in the future. Okay, for now we're going to use an extra module, was basically a hello world example from its documentation that would allow us to read either an array of JSON, or which is a valid JSON document, or just a bunch of JSON object, which technically is not a valid JSON, but it's kind of useful in in the real world scenario. In our case, we're just going to use an array of JSON, right? So we can actually close the application JSON, and we can actually go to the data JSON over here, and just convert it into array. So we're going to say this is going to be an array. Okay, and let's also clone this one a couple of times like this and like that. Okay, so let's say key one. And so like this is going to be like the first object, and let's say it's just first, and let's do 1 over here, let's do 2 over here, let's do second over here, let's do third over here, and let's do 3 over here. Okay, so yeah, we're done with the config stuff. So let me remove this and let me revert this. Okay, so without fs2, we can just say that we're going to read this thing into a sequence. Okay, a sequence of data. Did I do it right? Yeah. Okay, so It's very simple, but imagine that this thing has like, I don't know, thousands and thousands of JSON documents. So what fs2 allows us to do is it allows us to read this thing in, chunk by chunk. Okay, and as a reminder, again, fs2 is a pretty advanced library, so I'm not going to be able to explain everything in every little detail. One day we're going to take a closer look at it and take it for a proper spin. Okay, for now, let's just go and add a couple of dependencies. So we're going to go to our build and we're going to do circe fs2. All right, so this is the integration with the fs2. Let me sort this. Okay, it's actually sorted. And also we're going to use the actual fs2 library. We're going to use, so it's also modular and it has another module which allows us to read stuff from the file, right? So it's fs2.io. So we're going to go over here and we're going to do code.fs2 and it's fs2.io, okay, and it's going to be 2.2.2, and it's going to bring in the dependency into fs core, but as I already mentioned, because we can, let's also add it manually. Okay, fs2 core. All right, yes, please import our changes. And oh, I forgot to add one. Hold on, cancel. We actually need cats effect. So if you've never touched cats effect, it's essentially a concurrency library. Well, technically it's a library for effects. So it defines a lot of type classes and a lot of instances for these type classes that allow you to describe concurrent computations. And so we're going to go and we're going to do org.type level, and we're going to do this, and we're going to do cats effect. The version is slightly different. It's 2.1.2. Okay, yes. Now please go and import the build. Okay, so what we're going to do is we're going to actually so we're still going to use our data, and we're still going to use our key 1, but we actually don't need this entire main. So just for simplicity's sake, I'm just going to comment out this entire main, and I'm going to create a new file, and I'm going to call it fs2 main.scala. All right, so it's going to be like this. Okay, it's going to be like that. Okay, right. So with functional libraries, we always just describing things, and in cats, I'm not actually sure if it's in cats or in cats effect. It's probably in cats effect. So over here we were doing, extends app, and in one of these libraries we actually have an IO app, and IO app, it basically just has a different function for running, and it needs to instead of returning unit, it actually needs to return an IO of unit. Technically it's not an IO of unit, it's an IO of return code, but that's not the point. All it does behind the scenes, it will actually call unsafe run sync for you. Technically it does more because it's actually designed for concurrency, so it also has, thread pools behind the scenes, the execution context and timers and all that stuff. But all of these things are abstracted away from you. All you need to do is you need to go over here and say object main extends IO app. App is small, like this. Okay, and now we're going to ask metals to, first of all, we need to import it. So we're going to import cats.effect, and we're going to have exit code, we're going to have IO, and we're going to have IO app. Like this. Okay, so now we have our answer. IO app actually comes from cats effect. Okay, so now we just need to ask metals to implement the function for us. Come on, inline it properly. Okay, like this. All right, so for example over here we could just do IO print line hello world, and then it's just going to be work just fine for us. Found unit required exit code. Okay, so we also need to do come on, where is it? I want a star like this, and we need to do exit code dot success outside of the IO, of course, like this, and it comes from cats implicits. What did I do? Come on, just work. Okay, there we go. This is our hello world. Okay, so basically we're going to have a for comprehension first that has our our proper hello world, the one with the hyphens. So this is how you usually do it. You just have a for comprehension over here, and you just grab IO of print line. Let me actually copy this. So this is the thing that we're always doing. Okay, print line like this, and in the middle, let's actually clone it again. In the middle, we're gonna have that. We're gonna have. Come on, let me remove one of them. Hello world, like this. Okay, and you're just gonna yield yield the exit code dot success. So if you've never if you've never dealt with with cats effect or anything, like this is how you start. This is the hello world in the cats effect. So this has nothing to do with streams just yet. All right, so let's first go into our read JSON from thing and add yet another helper that would read our data from a stream. Okay. So usually we have like all the imports at the top over there. Let me actually create a bit more space and a bit more space over here. We could use all the space in the world for this one. Okay, so let's go down and add yet another one. And for this one, I'm going to have all the imports over here, and I'm going to use the explicit imports so that you see where all of these things come from. Because again, I know like fs2 and cats effect and all of these things are actually kind of a bit more complicated. And usually I record videos like this after I explain them properly, but for this one, I just couldn't resist. Okay, so let's do Java Neo file path. Okay, let's do cats effect, and we're going to bring in a bunch of things. Okay, we're going to bring in the blocker, which is basically an execution context that is going to be blocking. It's going to block the current thread, and so it's going to make sure that it adds a thread if you run out of threads and so on. We're going to bring in the context shift, which is basically an execution context, which is basically just a wrapper around another thread pool, right? So both of them. Okay, and we're also going to bring in sync, and sync is the first type class. It's above all the other type classes in the cats effect ecosystem. And if you've never dealt with anything like this, basically think of it as IO. Okay, sync is the same as IO. Just for now, yeah, that's all I can do for now. Okay, so now we're gonna import fs2, and every time you're importing fs2, make sure that you use explicit imports, because you're gonna use words like stream, and stream is also defined in the standard library, even though in Scala 2.13 it's being replaced with lazy list. However, the streams are still there. Okay. So we're going to bring in the functionality that can read stuff from a text file, and we're going to bring in the actual stream. Okay, so we're also going to bring in import fs2 .io file. Okay, so I said it wrong before. Okay, so this one is the one that allows you to read stuff from the file, and this one is the one that allows you to convert the bytes from the file into text. Okay, so all this stuff that I'm doing, by the way, it's literally like on the first page of the fs2 documentation. Okay, let's bring in the integration with circe. So we're going to do circe fs2. So we're going to have a decoder, and here we're going to decide what are we reading in. In this case, we're reading an array, so we're going to do a string array parser like this. I believe this is all the imports that I wanted. We need a dot over here. We need a dot over here. All right, Scala FMT kicked in, and now it says object.io is not a member of package.io circe fs2. In fact, I believe I know what's happening, and what's happening is what I told you in the beginning, that you should always use explicit imports. However, at the top of the file, we're probably importing io circe, which is this guy. Okay, so let's import. Let's import everything. Okay, so let's not import fs2 like this. And yeah, so that fixed it. Okay, so we're basically importing everything but except for fs2. And at the very, very bottom, we're deciding what actually to bring in from the circe fs2. We want the decoder, and we want the string array parser. Okay, so let's finally define our helper. It's going to be called path into stream of. And this is going to be a bit complicated. This is the final tagless style. So we're going to say we're going to be able to read this stream into any sort of sync. In our case, we're going to use IO, and we actually could have hard coded this to IO, and I'm going to show you how to hard code this to IO in just a second. But I just couldn't resist, because like this way, it's more clear actually what we're doing, unless you're not used to final tagless. Okay, so we're going to say that this thing is going to work for any f which accepts a parameter, as long as this f has actually an instance of sync, and it also has an instance of context shift, right? So these two guys. Okay, and maybe we can actually sort them. Okay, so we need the context shift, and we need the sync. Okay, it's going to have another parameter. It's going to have another parameter, which is the a, which has the decoder, right? So this one is the same as we had before in all of them, right? So all of them, they needed a decoder for a. Okay, so now this thing is going to need a path, which is comes from Java file neo path, and it's going to produce a stream of fa. Okay, so in our example, it's going to produce a stream with io of a. Okay, but this is how this thing works. Let's see if I made any typos, and it looks like I did. Okay, great. So the way we do this is we're using the stream.resource constructor. Okay, and we're asking it to find the instance for blocker, for f. Okay, and it's going to be able to find it because it has everything that it needs for it. Okay, after it found it and it sorted it into this, we're going to do flat map, and we're going to have our blocker over here. Okay, this is basically our execution context. In fact, maybe we can jump into the blocker and creates a blocker that is backed by a cached thread pool. Okay, so if we actually go to blocker, come on, please jump in there, please. Come on. There we go. So a blocker is an execution context that is safe to use for blocking operations. That's pretty much all you need to know. Okay, so now we're going to have our blocker. And now over here, we're going to use the file, which is this one, comes from fs2io.file. Okay, and we're going to say, please read all the bytes for f. And by the way, this is one of the things that if I don't forget, I'm going to show it to you. If you're new to final tagless or to dealing like with a lot of type classes, if you forget to instantiate to specify one of the types, your error message might get crazy. If I don't forget, I'm going to show this to you. Okay, so now we need to give it the path, which comes from here, right? And we need to give it the blocker, which comes from here, and then we need to say, you know, how many, how big every chunk should be, and the default uses the 4096 bytes. In our case, this is way too much, right? So this basically means that it's going to read this entire JSON into one chunk. However, for our cases, we don't really care. I just don't want to deviate too much from the, you know, from the standard documentation. Okay. Now we're going to use a method called through, which is exactly like map. So if you have a list of A, then map is going to take a function from A to B. Through is exactly the same thing, but it doesn't take a function from A to B. It would take a function from list of A to list of B, right? So over here, it's a function that goes from stream of A to stream of B. And in fs2 terms, this thing is called a pipe. So it wants a pipe, and we're going to use the pipe that comes from text. So this one, and we're going to say, please decode the bytes into UTF-8 text. Okay, and after that we're going to use through, and this one is going to be using this one. Okay, so this first one, it came straight from fs2. This one comes from the circe fs2 integration. Okay, and then in the end we're going to have the last pipe, and we're going to say please use the decoder, which comes from the integration. Okay, decoder for f and a. All right. So if I did everything right, everything should compile. And let me show you, I believe, like if you remove like one of these f's, for example, this one, your error message might look, okay, in this case, it actually worked just fine. Let me do, that's actually a bad example. Okay, right, let's leave this one like this. Okay, because in this case, it actually worked. But occasionally when you're dealing with final tagless, forgetting to specify the type might actually produce a really weird error message. Okay. All right, so this is basically the entire code that would read this thing in there. Let me actually show you a version that does not do this final tagless, you know, stuff. Let's just let me copy this, okay, and let's say IO over here, okay. And now instead of all of this stuff, we're just gonna say, okay, it's gonna need an A, okay. Okay, and it's going to produce a stream of IO. Okay, which do we have it? We don't have it, right? It's in cats effect. I forgot. Yeah, it's in cats effect. Okay, we actually don't have it, so let's actually also import it. Okay, so it's going to be a stream of IO and A. Okay, so if we try to call path into stream of IO A and give it a path, right? So we're basically calling this one. It's going to fail because it still needs a couple of things. And now it's going to say cannot find an implicit value of context shift. Okay, so you need to go over here and you need to say, okay, I need to have an implicit context shift for IO, right? We can't use this like context bound notation because our f is now somewhere else, right? So our f is not hard-coded, so we need to swap this thing in there. Okay, and now it says, oh, I also need the decoder. Of course, you also need the decoder for A. Okay, so usually you would like to use these context bounds because if you look closely, we're not using this variable anywhere and this variable either. Okay, so we just need these types like to sort of float around the scope. So this is like a little bit less code. Okay, so this is how we could have done it, right? This is how we could have done it, but I chose to do this thing. Okay, I'm actually gonna leave it in there. All right, so now let's go back to our main, fs2 main. this one. Okay, let's bring in a couple of more imports. So the first one is going to be the same as, it's similar. So we're going to do java.neo.file.path, because for some reason I actually couldn't read this thing from the resources. I'm going to show it to you in a couple of seconds. Okay, so we just need to bring this. We also need to bring in fs2 stream, and we're also going to bring in io.circe.generic auto. And also remember that what we're going to be reading in is going to be still this data thing, right? So I left it not commented out, and so we still need to use like these two imports. Okay, these two, right? These ones, and I forgot to sort them over here. I like to sort things. So what we can do now is, like, before we do this thing, and usually often in examples you will see that the stream is being constructed even before the run, because again we're just constructing descriptions. We're not doing anything, so we can do actually stuff before the main. Okay, but in our case we actually don't really need it. Okay, so we can do stream, and we can do stream io of data, and we're going to implement it somehow. Okay, and I need curly braces, like this. Okay, so now obviously it throws an exception because it's a val. Let's make it a def for now. Okay, so after we read this in, so instead of this hello world, we're going to take the stream and we're going to say something like map to print line, right? Because all we want is to map it to print line. And over here we can do some like take two, just two of them, and we can compile the whole thing, and we can decide to drain the whole thing like this. Okay, so now it's going to throw an exception because we're throwing an exception. Okay, now let's actually go switch it back to a val. Okay, so what we're going to do over here is we're going to do path, which comes from Java. Okay, I'm going to say get. Okay, and over here I'm going to do /target, and I'm going to explain you why in a couple of seconds. 213, and we're going to do classes, and we're going to do data.json. Okay, and we just need to pipe this thing into read JSON from path into stream of so we can decide over here, right? So we can just go straight to IO, okay, and just specify data like this. Or as you can see, it already worked. It took only the two elements because we have take two over here. Let's actually remove the take two, and it's gonna take like all of the three elements. Okay, or we can say just like this, IO and data, and it should be fine. Okay, so this is exactly the same thing. One is like in this final tag list style, the other one basically hard codes the IO. Okay, now the problem with this is the following. So we have this resources folder, okay, which copies our data.json into target once we compile stuff. So it's over there, classes data.json. Now in the past, when you would get the resources, it would actually give this thing for you. However, I believe since SBT 1 or whatever, when they switched to the server and whatever, so this like get resources thing, it actually gives you some weird stuff. And before, in our examples before, it actually worked out because this weird stuff was accessible. However, fs2 is designed to work with these paths, and in order to construct a path, we would need to go and we would need to do something like, okay, let me actually show this to you. Okay, so we need to do get. Okay, and over here we used to do this, right? We used to do get class, get class loader, and then get resource, and we would give it the resource, which is data.json. Okay, and now this path thing, it wants actually a URI, so we would need to do two URI. Okay, like this. Now it's not going to work like this for some reason. Not for this reason, data.json. Okay, so it compiles, but it throws an exception. The reason is that, let me tap this one. So the reason is that look at this path. It's some weird path, and it's inside of jar file, and for some reason, for some reason the path cannot read it out, which actually pisses me off. I have no idea why. If you run this thing in Bloop is actually kind of even worse, because for Bloop this thing actually would work. Actually, let me show it to you. Brun JSON playground. Okay, so for Bloop this thing actually worked, but look what it did. It actually went to my source folder, right? So this is even worse than than this other thing. Okay, in any case, let's go back to SPT. Let's switch back to just doing this, and we're actually pretty much at the end of our fs2 example. Let's go back, and and run it. Yeah, so there you go. This is how you can read this thing into a stream. And as a reminder, I'm going to upload this thing to GitHub so that you have this full example. But again, like if you look at the first page of fs2, you're going to see almost literally, this code copy paste. Now again, this was probably a bit too fast for fs2. One day we're going to take it for a proper spin. For now, we're gonna make it even worse by cranking the complexity up even more. We're gonna play around with http4s, which is it's a library for writing HTTP servers.